Okay, going to have a look at the level 2 now. So the first one, the function is 3 minus 2x, x minus 5. And it shows you the graph there. Horizontal asymptote y equals minus 2 and another asymptote x equals 5. State the range of fx. So it can be any y value except for minus 2. Find the inverse. So you will set y equals and rearrange it just in your normal way to get x equals and replace at the end. The domain of the inverse is the same as the range of the real thing. To get the range of the inverse, I drew it out, and I can have any value except for, that should be minus 5 there. Now, the next one we're going to look at is part 3. It's a bit of a tricky question here. It says the gradient is 7. The inverse is whenever you reflect in the line y equals x. So the y was 5, that's now the x is now 5, and the inverse is 1 over, so it's 1 over 7. Number 2, state the range. You can see I drew it out. F goes into F. So here is my F going into my F again. Make the bottoms the same, and then bring the turn it upside down and tidying it up. Over the page, number 3, or part 3 of number 2, is find the inverse. So just your standard y equals, rearrange it, and then replace y with x's and replace x with your inverse. The domain is the range of the whole thing. And then to, and just check the next bit here, you have to find the range. So I sketched out the graph to do a bit of work to make it a bit easier, and sketched out the graph to help me see the range. Question 3. It's not too bad. So just draw your graph to get the range. F goes into G, G goes into G, and then we'll look at part 4. So the first few should be fine to work your way through the answers there. Now, whenever I want F, G inverse, I need to find FG first. So this is me finding FG. So I've now got FG. You rewrite that as y equals. Rearrange to get x equals, and then replace x with the inverse and y with x's. Number 4 is using the E function, so it should be okay. Wouldn't be too concerned about that. Should be able to follow that one through. Number 5, so a wee bit here, number 5 I have to show you. So in number 5, G goes into F, that's fine. It's the FG one I'm looking at that I want to draw your attention to something. So FG you've worked out, inverse of that, so set y equals it, rearrange it. Now the inverse only exists for a one-to-one function. When you bring sine over, do the inverse of sine, there are lots of different answers there. There's this very special type of trig, and it's called arc, A-R-C. Arc sine means there's only one particular answer to the inverse. You will see arc cos and arc tan later on, but that does come up later on in the course. But this wee question here is just making reference to it. So don't worry what that means at the minute. All you need to know is that means it's a one-to-one. And that's all of that wee section done.